Hey guys, I need to go back and recap some of the notes that we took today. Here we're talking about the idea of binomial setting, because remember the sections that it's in, the 5th edition, 6.3 and 8.1. And I'm just going to jump into it. Let's remind ourselves the formula. So we see the combination of n choose r, where p times the probability of success to the r power, and then the probability of failure to the n minus r, which takes me to this. So remember, this is the total number of possible outcomes. Here, p represents success, to how many do I expect to succeed. And failure means, of course, the number that I had total, and subtract that from the ones that were successful. So with that being said, I want to jump to page 16 of your notes and look at problem number 76. And as we look at problem number 76, go ahead and read that. It was nice enough for them to tell me that it was binomial. But let's confirm that it is. Okay, I think I'm changing it from bins to tens because I like the idea of two-ness. So here, remember, the plants either died or they didn't. So that does mean that it's binomial so far. Okay, they are independent because one's plant death is not affected by the other. And as I said in class today, that's kind of questionable, same soil, etc. But they told us it was binomial, so I'm going with it. Fixed number of trials, the fixed number of trials here is 10. And then your S, your probability of success, and in this case, success is the death of the plants, is 5%. Please remember, success is not always positive. Now, since I'm looking here for the probability of where we have exactly one of them correct, let's take that and plug this into our formula. Here is the combination of 10 choose 1. I had 10 barrel roots there. I'm only looking for exactly one to die. A 5% chance of the death. Again, I'm looking for one to die, which means here the probability of failure, in this case failure is good. Those are the ones that did not die, and those are the number that didn't die. So we take those and we crunch them into the calculator. Remember, this CNR is under the math function. So as I go to another copy, in our calculator we find the math button, we go over to probability, and then we go down to CNR, and then plug that in, and then we see that we get 0.315. However, like everything else, we can do it in the calculator. So we've got to find binom PDF. Okay, so in order to find binom PDF, we go over to second vars, the button, then we scroll down or up to normal PDF, which in my 83 is number 0. And we press that in. Here, notice what you're putting in there. You're putting in the total number of trials, which in this case is 10. You're putting in your probabilities for success, which right here is 5. And then here, the outcome that we desire, which is 1. And once you put it in, you're going to get the 0.315. Okay, now remember, calculator talk only is not acceptable, and so we still have to show this work. But now let's look at problem number 78. I believe it's 78, let me check. Okay, so go ahead and read problem number 78. Now, they're asking for the probability of it being 3 or more, which means here the probability of 3 or more is the probability of 3, 4, 5. Got tired of writing all that, so ... Then the probability of 10. Now let's think about our options. Are we going to do the combination of 10 choose 3, the combination of 10 choose 4. Let me start this and see if you want to do all this mess. So this is what I'm saying. Okay, here's the probability of exactly 3. Here's the probability of exactly 4. I've got to do this and so on until I get to the probability of exactly 10. And then I've got to plug all that into the calculator. Oh, no, 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 no. So that takes me to the idea here. I want to do it 2 separate ways. I do have another option, which is right here, which is the probability of finding 0, 1, and 2, because that's not what I want. And then I'm going to subtract that 1 from what I don't want. And here, doing the exact same thing, except I have the combination of 10 choose 0, and here's the 0, 10 choose 1, and here's the 1, 10 choose 2, and here's the 2. But wait for it, there's another way. We can use binom CDF. And you know the C stands for cumulative. Okay, so how would this be put into the calculator? I'm still going to be using 1 minus the probability of 0, 1, and 2, except I'm going to be finding the 1 minus binom CDF, which means that here, the fixed number of trials is 10. Here your probability is 0.05. But here I'm putting a 2. Why? Because this right here includes the probability of the 0, 1, and 2. And I want everything that's 3 and above. So I've got to tell it by saying a 2, it's going to max out at 2. It's going to give me 0, 1, 0, 2. I'm sorry, I'm saying it wrong. It's going to give me 0, 1, and 2 for my probabilities, which is exactly what I don't want. So it's 1 minus what I don't want. And when you put this into the calculator, you're going to see that you're going to get 1 minus, here the 0.9884, which is going to be 0.0115. Okay, so go ahead and do the homework that I mentioned on Remind, and be ready to talk about this tomorrow. Talk to you later. Bye-bye.